No, thanks a lot. Today we are going to talk a little bit about indoor navigation. My name is Sascha Kiener. I'm the founder of Svarmony, and I'm working in AR for the last more than 10 years already. So I started in 2012 working for a company called Metaio in Munich that some still might know. And I started my own startup, Augmentaio, in 2015 after Metaio got acquired by some big technology company. And so 3 years ago, together with Innovation Rocks, we formed the new company Svarmony to be a technology provider for AR technology, especially also in the field of indoor navigation and also offering solutions to our customers. So basically, accurate indoor positioning is a very important puzzle piece in the whole world of extended reality or augmented reality that will allow to merge both worlds into each other even more seamlessly, the real world and the virtual world. And we want to really be able to place content where it belongs to, in any building, in any size of room, anywhere. So this is also why our team really worked for the last 3 years relentlessly on this solution so that we can present you today and that you can also experience a little bit later. So first of all, let's start with a quote from John Henke. He's the CEO of Niantic, and he said, "Shopping, playing, having fun, AR can make all those things better." And we also believe in that. That is also one driver why we want to have this indoor navigation running and why we want to bring this into the world. More and more large tech companies, as we can see here at AWE also, are going into the world of XR or AR. We have also Meta here, for example, showing new hardware in this field. And basically, these companies start speaking more and developing more and more into these everyday wearable hardware. And this is also something that will really push the whole industry forward. So basically, what's one of the biggest problems of AR in the past? In the past, it was actually to really link the digital content to the world around you and link it with physical objects and spaces. There's different technologies around for the last years already where you can track objects, you can track 2D images. You can also go more, now it goes more with the wearable devices, it goes more into spatial AR. So this got really common now that you can basically scan your room around you. The glasses know where you are in the room so you don't run into walls when you are playing your game on your VR glasses. This is also a very good step to the next basically big step. And the next big step is to have spatial AR also for really large buildings and not just single rooms. Currently, there's like the standard technologies, most of you know, is 2D recognition, 3D recognition via point cloud, for example. There's edge-based tracking that uses CAD models to detect a car, for example, and that can show parts on the car, can show the wheels, can change the wheels and things like that. And there's the spatial tracking that most glasses are using. So our technology, or what we have worked on the last few years, is really to localize very accurately in a very large building, in a very large space. So who's Svarmony? First of all, we have, over the past years, really worked with a lot of customers, created a lot of interesting projects in the space of XR in general. So not just navigation projects, but also visualization of products, explanation of products, onboarding of employees, and things like that. And so we have a suite of different products. One of them is Aryve, the indoor navigation, which we will go more in depth into later. And then we have the avatar solution that's basically creating an ideal brand representative or digital guides, what is also used by Porsche, for example, to onboard their employees. When there's new employees, they get a web AR application with a little avatar from Ferdinand Porsche, and he's explaining them basically something about the company and about the history of the company. Our visualizer solution can really help bringing up product experiences. So we worked with Porsche and with Bentley, for example, to have to really show the car. These are all applications that you can download now in the App Store. So the Porsche and the Bentley application you can try out. You can also come to our booth later and just try them there, because we are showing them, of course, also. So basically, why do we at all develop a VPS? As I said, in the world today, the buildings that are built are getting bigger and bigger. Shopping malls are getting bigger, shops are getting bigger. Everything is like airports are getting bigger. It's all made for like to manage more people, and this also makes it very often just simply more confusing. Basically, the average floor space of these buildings can get really large. Also, when you go to the Arab countries, when you go to the US, and you see a shopping mall there, it's such a large space that it's really difficult to navigate through this. With an accurate visual positioning system, you will see your path illuminated, like you can see on the image, and you just basically have to follow the breadcrumbs to find your goal, to find your destination. So right now, this is one of the typical floor maps everybody of you knows. It's very confusing. It gives you a little POI with you are here dot. And this can get really complicated to remember where you have to walk. You have to go right, you have to go 50 meters straight, and then if you're lucky, you get to the right room where you want to go. And this is like, let's say, the most low-tech solution in this case. There's also other solutions already that use maps like Google Maps indoors, that you can see a dot on the map, and then you have to follow the dot basically on a 2D map. This already is one step further, but with this kind of technology, it's still 2D, so you cannot really track, or you cannot really show information in the 3D space around you. You can just see the little dot on the 2D map. And this can also get very confusing at some point. So you have a compass, you know the direction approximately, sometimes it works, sometimes it doesn't, and it can get confusing to know where you exactly have to walk. So following the breadcrumbs is basically a lot easier. So this is also why we have worked in the last years to make this navigation just more exciting and more accurate, basically, in the end. So where can it be used? There's many use cases for indoor navigation, of course. There's like shopping malls, there's big retail stores when you want to find a product in a Best Buy or in a MediaMarkt, and you can't find the cable you're looking for. Therefore, you need a really accurate navigation. There's also airports that can get really big. There's public buildings, of course, where you can get lost really often because they're often old buildings and they're really confusing to navigate through. And of course, big offices, train stations, hospitals, art galleries or museums, and hotels. And there's even more places and more use cases you could use this technology for, even for navigating blind people, for example, through a large environment where they don't know exactly where they are. And the navigation can be via audio also, because as soon as I know where they are, I can give them some audio. So now we see if we have some sound. So this is basically a brief explanation of, we don't, of how Aryve works. This is basically, we are taking a point cloud with a LiDAR system that is basically, we walk through the building before, we take the whole scan, and then we create the point cloud and images out of that. And with the help of the point cloud that is very accurate in the end, we can create the navigation experience. So basically, this is a navigation tool or a navigation solution that combines a really accurate camera-based indoor positioning with indoor navigation in AR. So basically putting the content on the position we get before. So basically, locating the content or locating your data can be either on a server or it can be in the building locally also, if there's problems with data security and things like that. The data does not have to leave the building, even though we are connecting to a server. So, and the computer vision approach makes it more fast, it makes it more responsive, and it's also, you don't really need additional hardware to install in the building. So you don't need Bluetooth beacons, you don't necessarily need Wi-Fi, you just need a little bit of internet, so we can send one picture every few seconds to the server and can get a new position back. So this is basically a little overview about like why or what other technologies are there on the market right now that you can use for indoor navigation. First of all, we have GPS, but you can't use that because it doesn't work. It only works outdoors. There is indoor GPS as well with a limited accuracy, but it's not really a good use case to use indoors at the moment. Then there's wireless technologies, such as Wi-Fi triangulation, for example, that gives you an approximate position via Wi-Fi. And there's also like really, let's say, really fancy technologies like the ultrasound light that uses basically lights in the ceiling and the frequency of the light to detect under which light you're standing. And it also gives you a position. And there's also technologies like magnetic field, where you have to record. You walk through the whole building with your phone. You record the magnetic field in the building, and then you can start a navigation based on that as well. These are also all basically only usable for map-based navigation, not for AR navigation or XR navigation, showing any kind of XR content. So this is another example where we basically started one of the first bigger demos. That's in the Deutsches Museum in Munich. It's one of the biggest history technology museums in the world. And we have set up the navigation there in the main hall. So this is how it works. This is the UI from the app right now. And then you basically just lift up your phone, you point it into the room, and in a few seconds you will get a position that's very accurate, and then you can choose where you want to go, and it will just navigate you there. You can also put in 3D content, of course. You can put in videos, any kind of animation, anything, even a virtual avatar, basically, that walks in front of the visitor and shows them a special tour about things of interest for the visitor. So basically, how does it technically work, or how do you set up the whole indoor navigation? Because this is a difficult and important point for many customers, is we want to set it up fast. We don't want to have really high, really high involvement in that. We want to have it quick. And so, how does it work? So basically, the first step is we build a map based on a LiDAR scan. So we use a LiDAR scanner. The one in the middle is like one from Leica Geosystems. There's different ones. The thing is, these LiDAR scanners, they all have the same basic raw data format. So we can even use when there's a customer or there's a shopping mall that already has done an indoor walkthrough for the website, for example, and they scanned everything with a LiDAR scanner, we can take their data because it's a standard, it's a data standard, basically, E57 for LiDAR scanners. So we don't necessarily have to do the recording every time. If there's already data there, we can also use that. So basically, before we, in the first tries, and also the first tries for indoor navigation, there was an application that you loaded on your phone, and then you had to walk around in the room and record the whole room. Everybody who's a little bit deeper into AR and into recording and into 3D scanning knows that loop closing is a problem in AR. So when you are walking through a really long hall, there will be some drift and there will be some error, and in the end, the map you created doesn't fit on the real 2D map, and then you have a big problem because you have to fit either the one map to the other or the other to the one. So that makes it really difficult to get accurate data in the beginning. And this is why we use LiDAR scanners, because we get really accurate and perfect data set in the beginning to do a localization. In the end, the LiDAR scan looks basically like this. This is from our office here in Vienna. And you can fly through the whole scan and you see exactly where you are. And we use this together with 360-degree images to do the localization on the server. Then the next step would be basically to set up in the CMS, to set up the CMS. So we have also developed a CMS system that makes it really easy to use, and you don't need any developer skills to use the CMS. You can just basically create a login. You can create an image or logo from your company. You can set up the whole CMS to your company CI, that it looks like exactly it's from your own company, and to make it, and then provide it the logins to your employees. Then, as a next point, you create a location. So basically, you enter like what the location name is, and some additional data for the location, and then you can edit the different floors of the location so that you can do the basic setup here. Here's an overview about like how your locations could look like. The CMS is programmed in a way that you can give different rights to employees, for example. Not everybody has admin rights. So, and some people should just manage maybe one branch of a store or something. So you can give rights directly for this special thing. Then the next step, basically, here you get a 2D map from your building, from your store, whatever. And then you can choose the position where you want to place content, what kind of content to place, and how it should look like. And if you want to place the content more accurately, like the height, for example, or put it above a table, or put it on a certain place inside, you can also click it and then fly inside in this 3D view that we saw before. And then you can accurately really place the content at the space you wanted. So basically, as mentioned before, Aryve is basically right now a native application, but we will have a web AR solution soon as well. So you don't even have to download the app. You can just scan a QR code, you hold up the phone, and you get an instant position of where you are without downloading anything. And this is a really good entry for people to download the app to get even more content and get even better, even better functionalities. This is just a little bit explanation of our image retrieval process. So how do we do the detection, basically? On the left side, you see a query image that comes from a phone. It's also in our office in Vienna. And on the right side, you see different candidates, basically, that are used for, that are chosen to make a correct detection. And then we are matching the points from the query image with the candidate, and we check basically what the position is, and then we are placing the content. The basic system looks like that. So we have the front end that can be either a web application or the native application. Then we have the core, that's the back end, the server side, where the 3D model of the building lies, and also where the positioning is happening. And then we have the CMS, where you basically feed in the data. It's quite simple. So over the past 2 years, we started 2.5, almost 3 years ago. We started with the inner navigation, and this is basically the percentage of how many positive detections we get from the images we send to the server. And at the moment, in the Deutsches Museum use case, we are at about 75, sometimes even more, percentage of correctly identified pictures. So that's also why we only have to send one every 2 seconds, basically. A little view into the future also. Of course, this kind of use case is really valuable on glasses. And we are a partner of Magic Leap and of HTC in this case, and also of Qualcomm with Snapdragon Spaces. And we are working really hard to bring this solution also on glasses. So as soon as the glasses are small enough, you can use them in the shopping center to navigate. At the moment, actually, we have implemented this solution already as a proof of concept in different locations. So as you can see, there's the Deutsche Museum. There's one shopping center in Berlin that's quite big, where we have a demo running as well. We expanded the Deutsches Museum also. So there is a second floor now in another room. So the whole size of the scan is around 6,000 square meters at the moment. And then we also did a demo at AWE US. And there's also a demo that you can ask for at our booth for this AWE here. So you can get a little walkthrough and you can try out the navigation. And there's another one running in Belvedere Castle, also here in Vienna, where we had a demo just before. So basically, what does it all mean? So this is opening a new world to all of us. So we can have basically a new layer of content inside real environment, inside real rooms, and it can really turn confusing corridors into a large world of interactive and amazing content. So remember, in the world of AR, not all who wander are lost. Some might be just enjoying the view. And check us out at our booth. It's booth number 248. It's really easy to find when you go into the exhibition area. It's on the back of the Meta booth. And yeah, we are looking forward to talk to you and to have you at our booth and to show you some demos. And now, if you have any questions, feel free to ask, please. Thank you.
Thank you very much, Sascha. And there's already a question, 2 questions. We will try to stick them in. All right, I will hold the microphone. Please say your name and what you do.
Hello, I'm Alex. I'm from Romania, developer. My question was, how do you deal with changing spaces? Like if you have a space and suddenly the furniture in it simply changes. How do you deal with stuff like that?
Yeah, it's a good question. There's, of course, when you have a retail store, for example, clothing stores, they change stuff all the time. There's a certain robustness to changes that basically where it still works, the whole thing. Also, when there's people walking around and things like that, or you're moving around chairs. If there's bigger changes, at the moment you have to redo the LiDAR scan, basically, of this part again. You don't have to do the whole thing. You just have to do like the certain part that has changed. But we are also going into basically self-healing approach. So where basically customers walking around with their phones, they take pictures anyway. So if there's changes, we can use those pictures to heal the map basically. And then the idea is that in the near future that you don't have to do any re-recordings. You just have people walking around and they improve your map while they're using the app in the end.
Thank you. Next question. I will hold it.
Okay. How do you deal with repetitive structures, for example, when you're in a very long hall, which looks pretty similar in each location? Mm-hmm. So how do you deal with that?
Yeah, so there's 2 things that are really, let's say, quite difficult. It's repetitive structures and it's like really shiny surfaces. So this is like everybody in AR knows that, like shiny surfaces are really bad. So the thing is, we can also use, if there's like any kind of other technology there, like Wi-Fi, or if there's like Bluetooth beacons, we can get a rough position and we can basically close down the position of where you are. That already helps a lot. So I mean, I wouldn't probably use it in a underground tunnel or in a car park at the moment because it's very repetitive. You only have the numbers. You have to use OCR to read the numbers and stuff like that, and then you know where you are. But there's different solutions. It always depends a little bit on the venue, what you want to record, and then you can use the different, like what is available there and what you can use if there's Wi-Fi and anything. But that is already a big help. So.
Next question here, the first row. I will hold it.
Hi, thank you for the presentation. Do you also have projects in outdoor spaces and especially focus on like very crowded public open spaces like big squares or anything? And do you face any different challenges over there?
Yeah, right now we mostly focus on indoor because outdoor is more or less solved, because outdoor you have larger spaces, so there's also, if you have some kind of inaccuracy, it's not that big of a deal. Most of the time, if you use GPS, you get a few meters of accuracy, and if you do, for example, a tour guide for a city and you have some animation there that's in front of a building, it doesn't really matter if it's like 2-3 meters left or right. So it's like this is not so much of a problem. That's why we concentrate mostly on indoors. But of course, the idea is also that you can merge from indoor to outdoor spaces at the same time, that you can walk outside, because often you have like trade shows and there's open spaces and there's outdoor spaces, and then you have to combine all this. But since indoor is the really hard part, we are doing indoor right now. And then we want to solve this. And outdoor, to be honest, we don't have really tested it outdoor yet. So we used it mostly indoors. But of course, we have things like changing light environments, changing weather, trees are getting brown in the winter and stuff like that. And it's like everything is changing, so it would be interesting to test that out also.
Would you say you do something like spatial computing? Would you think about that expression?
What, spatial computing? Yeah. Depends what exactly do you mean. With, like spatial computing, like Meta uses for the glasses, for example, or what you using your computer in the space, a virtual computer, virtual screens and stuff like that. It's a big word. It's like if you use XR, it's like it's a wide thing. But for me, spatial computing is mostly everything like just recognizing one room and placing stuff inside the room that you can basically use like a virtual screen or virtual keyboard and things like that.
Great. We have no time left, unfortunately, but Sascha is, of course, here, and you
Yes.
can meet him at his booth. Which number was it again?
248.
248. This was Sascha Kiener from Svarmony Technologies. Thank you
Wiener's
very
also
much.
good, thanks.